So they started to what? Yes, to classify or to make the order out of this chaos. So what is chaos means? Confusion and disordered way. Okay. So earlier times, first of all, they thought that only the elements are, yes, metals and non-metals. Okay, only the elements are will be in the form of metals and non-metals. The first very simple classification was that, but they discarded at that time itself because gases are there and also metalloids are there. So that is what actually discarded at that time. Not gases. I mean metalloids are there. Metalloids, non-metal. That is what the actual classification, general physical classification of metals, and that is what this metals and non-metal classification discarded at that time itself. Okay, so you don't bother about it. You just think or you just remember that such kind of classification also emerged at that time. Means metals are only existed as what elements are only existing as metals and non-metals. Somebody thought such like also, but that is not means very important to us now. So the first classification or first early attempt at the classification of elements was Dobereiner triad. What is Dobereiner triad? Please note the spelling also. Dobereiner triads. Okay, Dobereiner is the name of scientist, and triad means what? Tri stands for three. Okay, and what is the meaning? You can understand after reading this passage. Okay, in the year 1817, Johann Wolfgang Dobereiner, a German chemist, tried to arrange the elements with similar properties into groups. What he done? He tried to arrange the elements with similar properties into groups. Okay, he identified some groups having 3 elements each. Okay, 3 elements each. So I think you may got what is the meaning of triad. Well, means why the term triad is here, because the group having only 3 elements. Okay, Dobereiner's classification, the similar property means elements having similar properties are what constituting a group, and the group contain only 3 elements. That's why he called as Dobereiner triad. Okay, so he called these group as triad. Dobereiner showed that when the 3 elements in a triad were written in order of the increasing atomic mass. What? When 3 elements, in triad there are 3 elements, and when these 3 elements are written in the order of increasing atomic mass. You know what is atomic mass? Sum of neutrons and protons. That is what known as atomic mass. So while we writing the elements in the ascending order of their atomic mass, for example X, Y, Z, these 3 are suppose these 3 are 3 elements, and I am writing in the order of increasing atomic mass as X, then Y, then Z. That means Z have yes higher atomic mass, X have very less atomic mass, Y will be intermediate between this X and Z. Okay, so once again come to the point. When we are writing 3 elements in the ascending order of their atomic mass, then the atomic mass of the middle element was roughly the average atomic mass of the other 2 elements. What is it? X, Y, Z. We written as X, Y, Z. Okay. Then the atomic mass of the middle element means the atomic mass of the Y will be the average of the atomic masses of other 2. How can we find the average? Yes, other 2 are means what? X and Z are here. So atomic mass of Y will be the average of the atomic mass of X and Z. That means atomic mass of Y is equal to atomic mass of X plus atomic mass of Z divided by 2. That is what average. How can we find the average? Adding and dividing with the number. Okay. Adding and dividing with the number. Adding the particulars and dividing with the number. Okay. So, atomic mass of Y will be is equal to X, atomic mass of X plus atomic mass of Z. Here X and Z means X is 1, Z is 2. Means there are two numbers, two elements, X and Y. So these the sum of atomic masses are dividing with the number present, that is 2. X, atomic mass of X plus atomic mass of Y divided by 2. That is what the average atomic mass, and that will be equal to the atomic mass of middle one. That is what Y. Okay. For example, consisting of, take a triad consisting of lithium, sodium, potassium. Okay, lithium, sodium, potassium. Having lithium have the mass 6.9, sodium 23 and potassium 39. What is the average atomic mass of lithium and potassium? Means we are arranging lithium, then sodium, then potassium, because lithium 6.9 atomic mass. Then next higher will be what? 23, that is sodium. Then the higher one is what? 39, that is what? Potassium. So according to the Dobryner triad, the mass of lithium, atomic mass of lithium plus atomic mass of potassium divided by 2 will be the atomic mass of sodium. Let's check it whether it is right or not. So I think you have calculator, otherwise you have pen and paper on listening this class. So try to check it. Add 6.9 means do the calculation as 6.9 plus 39 divided by 2. You will get what? So this is what? True actually. This is right actually. So these are elements arranged downwards in order to increasing atomic mass. Here some arrangement, some atoms are some elements are arranged downwardly. Okay, group A, group B, group C. Now you take pen and paper, try to calculate which triad is okay and which triad is not. After calculation, you will find that B and C form Dobryner triad. Only groups B and C form Dobryner triad, not A. So that means what actually? Group B contain calcium, strontium, barium. Group C contain chlorine, bromine, iodine. And we already studied that lithium, sodium, potassium. Lithium, sodium, potassium. Yes. That is also showing what? Dobryner triad. So you got here 3 sets or 3 groups. First group lithium, sodium, potassium. Next one calcium, strontium, barium. Next one chlorine, bromine, iodine. So these 3 sets only shows what? Dobryner triad. Again, these 3 sets only shows Dobryner triad, means on adding the first atomic mass and the last one's atomic mass, then calculating what average, we will get the approximate atomic mass of the second one, and that is what applicable or that is true only for lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine. And this is not actually applicable for sodium, potassium, arsenic, what is provided you in group A. You can find that on adding 14 plus 74.9 and dividing them, we will get around 44 I think. 44 you will get 44 around something. So that is what not the atomic mass of phosphorus. Here the atomic mass of phosphorus is 31. So that is not true for this group. So this classification into triad was not found useful. Okay, only 3 triads he found can be what correct. Only 3 triads is only only 3 triad are only, again repetition is here. Okay, with the Dobryner triads, just like lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine. Okay, so rest of the members will not show this kind of Dobriner triad, so this classification is discarded. Now new kind of classification coming here, Newland's law of octave. What is Newland's law of octave? Octave stands for what? 8. Okay, octave stands for 8. So Newland, name of scientist, law of octave we are going to study. Okay, so Dobriner triad, just like Dobriner triad, you can understand tri stands for 3. Now you will get what is meant by Dobriner triad from the name itself. Just like after studying this passage also, you will get what is meant by Newland's law of octave from this name itself. Okay, so the atom of Dobriner encouraged other chemists to correlate the properties of elements with their atomic masses. But in 1686, John Newland, an English scientist, arranged the non-elements in order of increasing atomic mass. Here also he taken the parameter atomic mass itself. Okay, in the Dobriner triad he also taken the parameter atomic mass, increasing order of atomic mass. In Newland's octave he also taken the parameter increasing order of the atomic mass. So you should know what is atomic mass. Again I am saying sum of the number of protons and the number of neutrons present in an element, present in an atom, is known as what? Atomic mass. Okay, so he arranged the elements in the increasing order of their atomic mass. Then he started with the element having the lowest atomic mass, that is hydrogen. Means he started his classification from hydrogen and ended at thorium. Thorium is 56th element. He ended at thorium. He found that every eighth element, you please note it. Our heading is what? Newland's law of octave, and octave stands for 8. So you will get how the name came here. Okay, so he found that every eighth element had properties similar to that of the first. What is it? Every eighth element have the property similar to that of first. Okay, suppose 1, 2, 3, 4, 5, 6, 7, 8. You classified this as 1, 2, 3, 4, 5, 6, 7, 8. Then 8, the number 8 have some similar properties of 1. Okay, then again I am arranging 9, 10, 11, 12, 13, 14, 15, 16. Then the 16 have similar property with 1. Okay, so that means what? He found that every eighth element have the similar properties to the that of the first. Okay, so if so after arranging 1 to 8, 8 to 16, we will get that 8 and 16 have similar properties of 1. Okay, so we will classify or we will group the elements as 1, 8, 16 in same group, because these elements have what? Similar property. For example, you please note the table. Here arranged hydrogen, lithium, beryllium, boron, calcium, carbon, nitrogen, oxygen. So then fluorine. So 1, 2, 3, 4, 5, 6, 7. Oxygen is 7th one. The 8th one is what? Fluorine with respect to hydrogen. So suppose you are counting from hydrogen 1, 2, 3, 4. Then the oxygen is here 7th one, and the 8th one is what? Fluorine, and it is classifying in the same group of first. Okay, then again you are counting from fluorine, you are going to arrange. After sulfur, you will get the 16th one, chlorine, and that is also coming under the first group in the group of hydrogen. Okay, means every eighth element have the similar property of first one. So that is categorizing in same group. Okay, so come to the second line, lithium. Starting from lithium, taken as 1, then 1, 2, 3, lithium 1, beryllium 2, boron 3, carbon 4, nitrogen what? Yes, 5, oxygen 6, fluorine 7. Sorry, 1, 2, 3, 4, 5, 6, 7. Yes, fluorine 7 and sodium is 8th. So what happened here? We started from lithium and entered at sodium. The sodium is what? 8th element when we starting from lithium, and every 8th element have the similar property with first. Okay, so here sodium is 8th element, Na. Sodium is 8th element with respect to lithium. So both of these are coming under same group. Okay, I think you may be clear. Once again, when we are arranging the elements, every 8th element have the similar property with the first one. Okay, so when we started our counting from hydrogen, then the 8th element will be fluorine and it will come under the same group of hydrogen. When we starting counting from lithium, then the 8th element will be sodium and it will come under the same category of lithium. When we starting our counting from beryllium, okay, third one, and the magnesium will be the 8th one. Okay, you please count down. Beryllium 1, boron 2, carbon 3, nitrogen 4, oxygen 5, fluorine 6, sodium 7, magnesium 8. So you please note it. When we started beryllium, entered at magnesium, the beryllium and magnesium came under same group. Okay, so always we have to start from the first one. Okay, first one means first one is hydrogen because he started his classification from lowest atomic mass up to 56th one. Okay, so this is what about Newland's law of octave. It is a kind of what? Yes, musical note, just like sa ri ga ma pa da ni sa. Again the sa is what? Similarity with the first one. Okay, musical note, just like musical note. Okay, you please note it, just like musical note. Now, law of octave. In Newland's law of octave, the properties lithium and sodium were found to be same. Sodium in the 8th element after lithium. Similarly, beryllium, magnesium resembles with each other. Okay, beryllium, magnesium resembles with each other, just like boron, aluminium resembles with each other. You please note the what? This 5.3 table also. Okay, what I already told you, how this beryllium, magnesium resembles with each other, how it will come. When we starting the counting from beryllium, then the 8th one will be magnesium, and both of them shows similarity. Okay, now it was found that, but this classification is also not extended because it was found that law of octave was applicable only up to calcium. Okay, this is applicable only up to calcium. After calcium, every 8th element did not possess properties similar to that of the first. Okay, so you please remember, this is applicable only up to calcium. Okay, it was assumed by Newlands that only 56 elements existing in nature and no more elements would be discovered in future. So that is also discarded because now 4 elements are present. So he classified only 56 elements and he thought that no more elements will be discovered in future. That is wrong. So that's why again this is discarded. We can say as this is discarded due to this point of view also. Now several elements discovered and which do not obey this law of octave. Okay, now third point is what? In order to fit element into this table, Newland adjusted 2 elements in the same slot. Yes, you can see that in the first group, cobalt and nickel are arranged in the same slot. This is impossible because no different elements have similar properties. Okay, No, different elements have similar properties or similarity in all respect. So this is what wrong. Okay, now unlike elements under the same node, can you find some examples of this table 5.3 node that cobalt and nickel are in the same slot? And these are placed in the same column as fluorine, chlorine and bromine, which are very different properties than these elements. You know that chlorine, fluorine are non-metals, cobalt, nickel are metals. So this is very wrong here. Okay, so iron, which is resembles with cobalt and nickel, means iron is a metal. Cobalt and nickel are metal, but iron is placed far away. Far away. Iron is placed in the oxygen family, where oxygen is a gas. So that is what wrong. So thus Newland's law of octave worked well with lighter elements only. Lighter elements means up to calcium. The atomic mass of calcium is 40. So up to 40 atomic mass, the Newland's law of octave is working well. But after that, it is not working. So this classification is also discarded. So what is the actual classification? You have to study 2 more classification, and we will study in our next class. So I think you may be clear what we studied here. We studied only 2 types of classification, the Brenner triad and Newland's law of octave. So I am here a conclusion of what we studied today. Actually, the classification done as only metals and non-metals. Okay, metals and non-metals, basically. Then the Brenner triad. First classification, first earlier attempt to classify the elements as, and the first one is what? The Brenner triad. He done that, arrange the elements in the increasing order of their atomic masses. On arranging, then like that, he assumed that the atomic mass of middle one will be approximately equal to the average of atomic mass of the first and last one. That means X, Y, Z are the atoms or the elements. A of X, A of Y and A of Z are the atomic masses respectively. Then A of Y will be approximately equal to A of X, means atomic mass of X plus atomic mass of Z divided by 2. Okay, now this is able to make only 3 sets. Yes, this kind of 3 sets only he made, and therefore this classification is discarded. Okay, now this is what about the Brenner triad. And second classification on Newland's law of octave. You know, this is also according to which, yes, according to increasing order of atomic masses, means he also arranges the elements in the increasing order of atomic masses. Started from hydrogen and ended at 56th element, that is thorium. Every 8th element having the similar property that of the first. That is what Newland's law of octave, just like a musical note. Okay, now octaves, music, just like music's octaves. Now Newland's law of octave, this is known as Newland's law of octave because why? Because he told that every 8th element have the similar property of the first one, and this is actually just like the musical notes. So this is known as what? Newland's law of octave, and this is valid up to calcium. Okay, and he can only arrange it up to 56 element. So after that he thought that there will be no prediction or there will be no discovery of furthermore elements will be there, and that's why this is worked well for only lighter elements, that is up to calcium. Calcium have atomic mass of 40, and up to that only this law worked. So this is what the summary of our today's topic. You can make your own summaries, you can make your own notes also. You have to make your own notes, okay? After reading carefully, you should make your own notes also. So this is what I done, means I made a conclusion of our today's topic. So I think you may be clear. If you have any doubt, contact me. Okay, have a nice day. Bye bye.